Hi everyone. So today I'm back again with another video. So from today I'm starting another series which is from the code forces, and I'm trying to handle the code forces which has a rating of 1600 and even more than that. So I'll be focusing more on 1600 right now, and then slowly I'll start to improve myself and go to 1700 and 1800, all those questions also. So today I'm with a question which is known as partitioning the array. So let's understand the question first, and then we'll go through the examples and how we are flowing over the question, and then we'll find the solution of it. So the question is, we're given an array and will be given a positive integer k. We need to select a positive integer k. I don't know if we are able to see or not. It's very small, but it's fine. So we have an array, we have given an array, and we need to select a positive integer k that is a divisor of n. That means it is saying that it should be a divisor of n, means the size of the array. So Alan does the following. The first of all, he partitions the array into n by k disjoint subarrays of length k. So now what he means that if we partition this array and into k parts, into k size parts, so k will always be divisor of n. Just for example, if the size of the array is suppose 10, so the divisors of 10 will be 1, 2, 5 and 10. And so these can be the k values which we can take. And then if we are taking k as 1, so we'll divide this array into 1 1 1 groups. If we are taking this array size as 2, so we'll take 2 2 2 size of array in groups. If we are taking the size of the array as 5, then 5 will be like 5 in one group and rest of the 5 in another group, right? So this will be, and if we are taking 10, then there will be no group, or everything will be in the same place. We are considering the whole array. So this is what we are saying at first. Now what we need to do, we need to take another positive integer m, which should be greater than equals to 2, such that if he replaces every element in the array with its remainder when divided by m, then all subarrays will be identical. So what this means exactly is let's understand this by an example. Suppose we have an array as 131131. Okay, so I'm taking this as an example. So we are saying we have an array as 131131. Now k, so the size of the array is 6. So the factors or the divisors of 6 can be 1, 2, 3 and 6 itself. So these are the divisors of, so the k can take these values. So suppose if we are taking k as 1, so what will happen is it will divide the array into these many half, one element in every group. So these are the 6 groups, and every group will have only one element. Now he's saying we need to take a value m, we need to consider a value m, which when divided by every number will give a remainder. So if we place that remainder over here, now what we are saying is, let's suppose m is 2, just for now. If we are supposing m as 2, we are dividing 1 by 2, and whatever remainder we will have, will place that in this array. So if we divide 1 by 2, the remainder will be 1 only, because we are talking about integer, we are not going into decimals. So now if we divide 3 by 2, which is nothing, 3 by 2, so the remainder will be 1. All in all, we are doing modulo of 3 modulo 2, which will give us the remainder 1. So and again 1 modulo 2 will give us remainder 1, 1 modulo 2 will give us remainder 1, 3 modulo 2 will give us remainder 1, and 1 modulo 2 will give us remainder 1. So you see now they both are identical. They are identical subarrays. So if they are identical, then we can say that this is a good subarray, what we wanted in our answer, and we need to count the points, number of points that he will earn, like how many possible uh, values we can have, how many possible I would say subarray we can take that this condition will be satisfied. So if we take sk as 1, I see we can make all the subarrays as identical with taking m as 2. So we can say this is a good array, so we can increase our point as from 0 to 1. Now if we take k as 2, the groups will be divided as follows: 1 3 1 1 3 1. So these are the groups that we will be dividing it. Now if we take m as 2, so again if we do the same thing with this, the remainder will be again 1 1 1 1 1 1. So now if we suppose if we take the array as a 3, let's suppose if there would have this value would have been 3, and this value would have also been 3, then also this will be identical. Even if we do 3 modulo 2, it will give me 1, and might be possible if moduloing with some specific value will give us another value over here. Like suppose if we modulo it with 3, and if somehow I can change the array just to give you a idea that what is happening. So let's suppose if we consider I want to make 1 2 1 2 and 1 2. So for 1 2 I need 1 and 2 as the remainder over here. So if we have array as 5, okay, 1 5 5 1 not 1 1 5 1 11 and 1 14. Suppose this is we can convert this to 4. Now suppose this was this would have been my array, and we selected let me make it more clearer. This is 11. Now this is our array, and we are selecting m as 3. So what will happen if we do 1 modulo 3 will give me 1, 5 modulo 3 will give me 2, 1 modulo 3 will again give me 1, 11 modulo 2 will give me 2. Now 4 modulo 3 will give me 1, and 14 modulo 3 will give me 2, if I'm not wrong, right? Now you see these subgroups are identical to each other. Now, 1 is same as 1, 2 is same as 2. Now this one is same as this 2 is if we select like two of groups, if we select these two should be same, and if we select these two should be same. Now this is our question, and we need to check if we select a group of 1, can we have any specific value of m which can make this array as identical? If yes, then I need to increase the counter. If k is 2, can we make this array as identical? If yes, we need to increase the counter again. So we need to check if it is possible or not. So suppose in the previous example for Craig group as 3, we have 131, 131. Now we see 131 and 131 is already identical. Even if we take M as 2, we will get 111 and 111, right? So this is also identical, so plus 1. So for this, and now if we take K as 6, K as 4, if we cannot divide a group in equal halves if we take K as 4, because the factors of 6 size array is not 4, neither 5. So only factor is 6. So for factor 6, we already saw over here for 6 there are like 1, 2, 3 and 6. Now 4 and 5 are not there. So we are not considering 4 and 5. We are only considering 6. Now for 6 size array, we don't have any groups to compare. If we consider this in a group, we don't have another group to compare to. So we can say that this is a possible answer and will increase the counter. So always there will be one answer. If there is like no possibilities, there will be one possibility that we are taking the whole array. Now I have another example just for understanding purpose. That this is an example. If we consider any value of k, this is 1, 2, 3, 4, 5, 6. This is also an array of size 6, and the factors will be 1, 2, 3, and 6. Now if we take k, any value of k, if we take k as 1, we'll get these groups, and we cannot make, even if we take m anything, it should be greater than equals to 2, and greater than equals to, if we take any value, even if we take 2, it will be like if we erase this, if we take a m as 2, it will always be like this will be 0, this will be 0, but this will be 1, 0, 0 and 0. So see, we cannot make every groups identical to each other. So this is not possible. If we take k as 2 groups, so 2, 6, 3, 6 and 6, 6. So this is a group. Now if we take m as any values, any specific value, then also we won't be able to process it. So this is what basically our question is, and this is how we need to figure out things, like how is it possible. So now let's go to the solution part and see what we can do to this. Now we know that if two values have to be equal, if x and y needs to be equal, have equal mod values, then it should follow this rule, like x mod modulo with the mod value. The mod is nothing but m that we are considering. This should be equals to this y modulo m. Every time we see we have 1, if we need to make it identical with this value, this specific value, right, 3. So we need to modulo this 1 with some specific value m, and modulo this 3 with the same specific value m, and they need to be same. Now m will not change for any of these things. We just need to fix m and do this comparison, that if whether this let me erase it, whether these values are same or not. These values are same if we do modulo with m for this, modulo with m for with this, and these values are same or not. And then again these two values are identical or not if we do a modulo with m. These two values are identical or not if we do a modulo with m, and these two values are identical or not if we do a modulo with m, right? So this we need to actually figure out. Now if we simplify this equation, we'll get what? X and x minus y is equals to 0 modulo mod. Mod is nothing but m. So now we see, if we do this thing, x minus y, there'll be like if we do x minus y and find the factors for this, m can be anything which this value contains, right? Because this is saying that if we contain anything in m, it should be a factor of this x minus y. So if we take an example like 10 and minus 2, so we'll get 8, right? This is my x, this is my y. If we do subtraction of both 10 minus 2, that will give me 8. 8 has a factors of 2, 4 and 8, right? So if we consider m as 2, if we consider m as 4, if we consider m as 8, we can say we can make these values equal. Let's take let's consider m as 2. So we have 10 in one group and we have 2 in another group. Now we want that these two should be identical if we modulo with some specific value m. Now if we do m as 2, we see this will become 0, this will also become 0, they both are equal. Now if we consider m as 4, this will give me a value 2 if we modulo with 4, and this will also give me a value 2 if we modulo this with 4. So these two are again same. If we take a value as 8, we can again say that this will give me a modulo as 2, this will give me a modular value as 2, remainder as 2, right? So again they are same. So see, if m is 2, they are same. If m is 4, they are same. If m is 8, they are same. So that means the equation that we figured out is correct. Now the only thing that we need to find is, for every value we need to have a single m. Now let's take an example and understand this very properly. Now suppose we have this array as 10, 4, 8, 4, and we are considering k as 1 right now. So we already figured that x minus y modulo, and if we find the factors of x and y, that number can be a possible m. I'm telling can be a possibility, right? That means there is something more, can be a possible m. Let's see why it is can be a possible, why it is not exactly the answer that we are thinking of. Let's see over here. So we have 10 and 4. So we need these two to be identical. So for that we subtracted 10 minus 4, we got 6. What are the factors of 6? 2, 3, 6. These are the factors of 6. Now again these two needs to be identical, right? So 4 minus 8, if we do 4 minus 8, we'll get 4. What are the factors of 4? We have 2 and 4, right? So m can be these two also. If we subtract 8 minus 4, these two needs to be identical again. So 8 minus 4 will get 4. 4 has a value of 2 and 4, right? So now we see there should be a common between all these three that we can take, and that is nothing but our GCD. See, 2 is also here, 2 is also here, 2 is also here. So everywhere we have 2. So if we do the GCD of all the subtracted values that we have, we'll get a value which is nothing but our m that we are figuring out, and this m should be greater than equals to 2. Now there is a catch over here. Catch is what? A simple small catch. Now we know, like what we need to do is we need to find k. We know k. We'll do what? We'll just iterate over one by one every value. If I'm not wrong, I created it somewhere. Yeah, right here. So if we know the group, if we have a group of size k, the first value of first group and the first value of the second group, subtracting these two, then the first value of the second value of the first group and the second value of the second group, if we subtract these two, modulo it, and do this till the end of the array and find the GCD of everyone one by one, then we'll be getting m. Now there's only one catch over here, is if we consider this as an array. Last time we had 10 4 8 4 as our array. If we now consider 10 4 8 8 as our array, now what will happen? The first two subtraction will give me 2 3 6 2 3 6, that we have 6 as a subtracted value and 2 3 6 as a factor. Now subtracting 4 8 will give me 2 and 4 as its factors for 4. And now if we subtract 8 minus 8, this will give me 0. Now GCD of these all will be somewhere around 0, or even it will give me 2. So if the GCD of this value is 0, we can say that we can still divide this number with the previous GCD values that we had, which is greater than 1, right? And if the GCD value comes out to be 1, so for example, if we take here 10 4 8 and 7, 10 4 8 and 7, so for 10 and 4 we'll have 2 3 and 6, for 4 and 8 we will have 2 and 4, for 8 and 7 we'll have 1. Now we see the GCD for these two will be 2, but after considering this it will be 1. Now we do not want m is lesser than equals to 2 in this case, but we want m greater than equals to 2, which is not satisfied over here. So if our GCD is 0, then also we are considering, because we know that the previous GCD are 2 and the previous values, if this value is getting subtracted, if these two values GCD is 2 and these two values after being subtracted is giving me 0, so they too can also be divided with the previous GCD that we have, right? So this is how we will be increasing. So that means we need to do, if m is not equals to 1, we'll be increasing our answer. This is how our code will, the logic will flow. Now let's have a look at the code. If you did not get anything, I would highly recommend to go back to the video and try to understand with taking some more examples and all those examples which are present over here in the example. So you can try these, and once you will get it, it will be very much easier for you to understand the code. So code is nothing. We are taking the array. We have this array. We have this array and the length. We are calling this total points earned method. And now at start we know that this is the length. I need to find the factors of this length. So if the length is 6, the factors will be 1 2 3 and 6. If the length is 8, the factors will be 1 2 4 and 8. So I'm finding all the factors, and the factors formula is very simple. It's the square root. Go till square root and find if n divided by I is giving me the actual answer, then this is a factor, else I and n divided by I will be our factors. So these are the factors that we are finding with the square root value. This will go to square root, and after getting all the factors, what we are doing, we are storing it in the factors array, iterating over every factors, taking that as k or size. If 1, then k size will be 1, and finding the GCD of all the numbers. Now m is 0, m is started with 0. Now we are doing what? M absolute value of the current value and current j plus k value, means every group's that positional value. We already seen over, if I'm considering the first value, then we are going to the next group's first value. So this is what we are doing. If we are considering the first value j as 0, then next group's k 0 0 plus k, next group's first value, and we are finding GCD with that. Now if GCD is not equals to 1, we are saying that we have earned a point and we are increasing the value, and at last we'll return the point and we'll print the result. So this is how we actually solve this question. If you have any doubt, do let me know in the comments. I'll try to answer as best as I can, and then we can continue. So if you do not understand anything, please I would highly recommend to go back to the video, watch this video again, because it took me a lot of time to understand and implement the logic for this and then solve it. So if you like this video, do like, share and subscribe. Thank you everyone. Let's meet in another video.